We are still talking about chemical magic and that we can combine things. Things might happen. We might get a reaction. Last week and the week before, we had this big experiment with pennies. And we took all the dirty copper off the pennies.
One disintegrated.
And we put it on a nail and a washer, and we copper coated these little puppies. Okay. And we found out that matter cannot be created or destroyed. It's always just there in some form. It might change, but it's always there. Sam.
Yeah, so I was at Zeke's house. It was his birthday party.
Right.
And Jack had a couple pennies for some reason. Well,
right.
Jack, so we had them. They were over 1982. And we scraped them on the ground, and then they became like silver color.
They were before? You mean more recent?
Mm-hmm.
Okay, so Sam, they were at Zeke's house.
And they scraped it on the sidewalk.
And they took the new pennies that we found out were just supposedly copper plated, the ones that disintegrated in my bucket because they weren't made of the right stuff. They weren't as strong. And so they said, if it's just copper plated, what's underneath the copper? I love all you little scientists. It was Sam Curley that didn't love science, just told me about it in a science experiment he thought of on his own. Whatever. Don't love science. I don't believe you. It was Zeke's idea. I'm looking for a penny now. Anyway, they wanted to know what would be under the copper plating. So they scraped the penny on the sidewalk, on the concrete. And it turns out it was silver underneath. So some sort of metal that's naturally silver, not copper. Very interesting. I like that you guys thought about that. Since we learned that the new pennies are just copper plated, and you took it a step further to figure out what they would look like underneath that layer. I love that. Thank you for sharing. All right. So we do know that matter can't be created or destroyed, but it can change, right? And there are different ways that it can change. Josie.
Are we supposed to have a worksheet? Because in the stuff, it has like that 10-page of
just stuff to read.
Reading, but then it doesn't have any assignment. Is that supposed to?
Yep, you got what you're supposed to have. Then you got the same thing we've got right now. Kaylee. Okay, so we're going to read and discuss. There was supposed to be an experiment at the end of today. Lacey, stop, pay attention. But the supplies did not come in time. I had to order them from Amazon. Nobody local had them. It was a special science. It's called filter paper, but it's not coffee filter.
Filter paper?
It's a fish store. Nope, it's not like a filter that goes in a fish tank. It's not like a coffee filter. It's a special scientific type of thing.
Wow, never thought we'd get it.
And Sean had no idea we would get so scientific this year that I would need to actually go to a science supply store.
You thought it was online?
On Amazon.
It's a science supply store.
It's an official science supply that has to be gotten. I can't just go to Walmart or Schnucks or Deerberg's. Grocery store. Okay. So let's read. No.
Store in Arnold.
A science store in Arnold? Oh, Deerberg's is a store in Arnold. Okay, here we go.
I was saying that you can't go to Schnucks because Schnucks is a grocery store.
Right, they don't have science supplies.
Yeah.
No. All right, I'm ready to read. Volunteers? Sequel.
Yeah, I'm not good at reading.
We're done. I'm sorry, Zeke. Hang on before you start. Stop talking, please, and be respectful for the person that is reading. Okay, Zeke, you can go.
Okay, here we go. States of matter. Matter has particular properties. One property of matter is the state in which matter exists. The term state refers to how the particles of the matter are behaving. Some scientists call the states of matter phases. A solid is a state of matter that has definite shape and volume. A solid's particles are tightly packed together and only vibrate in one place. A liquid has no definite shape, but it does have a definite volume. A liquid's particles are not as tightly packed and can flow past each other. A gas has neither definite shape or definite volume. Its particles have a space between them to move freely.
All right, thank you. Hang on, I want to review a little bit of this. So I remember we talked about this stuff a lot in 3rd grade. And I feel like I had hula hoops or something on the floor, and some of you were the solids, and I put a whole bunch of you in a hula hoop, and you really didn't have room to move. You're just kind of like, okay, here I am. And then I put like a couple of you, maybe 3 or 4 of you in the middle hula hoop that was a liquid, and you had a little bit of room to kind of move and bump into each other. And then I put like, I don't know, 2 of you in the gas hula hoop, and you could walk all around and move all around. You had plenty of space. If you think about it, if I'm thinking about something that's solid, all the particles that are too small for us to see, they're not able to move around. That's what makes it solid, because the particles are like packed together.
What about
really tightly? So I can't fit anything down in there. In a liquid, slime is kind of
Semi-solid.
in between, kind of a semi-solid. Okay? Its particles are not going to be as tightly packed as the solids, but it is going to be a little bit hard, like it's going to have more resistance to it than if I just stuck my hand in regular liquid water or something like that. Z.
What about cornstarch and water? It makes it where if you like push on it really hard, it's a solid, but if you put it in slow, it's a liquid.
Yes. Yeah, there are some solutions that kind of try and defy the rules between solid and a liquid. You are correct, but and it really is sometimes related on how much pressure is applied to it. But a gas, that's the air around us. There's no resistance. I can move my hands everywhere, and the little gas particles just get out of my way, or I knock them out of the way. I have plenty of room, and I'm getting no pushback at all.
I have something about water. Like if you fall on water from like a long way up, it'll break all your bones and you'll drown. But yeah, so it's so hard if you fall from a height. So like the pressure has something to do with it, because if you fall on water from like at least like 15 feet, it'll hurt really bad. Or break
like a belly flop.
Yeah, and then if you just like jump in water feet first like a pencil, it doesn't do it. Like you just go straight in.
All right, so think about this. If there is enough pressure, you can fall through anything. If I drop something from outer space, it would fall
through the
roof, through the table, maybe even make a crater in the floor. Right? Okay? I'm sorry, some of you are really off track here, and it's annoying me to the point that you're about to go in the hall. I've told you, I am so done playing with you guys. You're almost 6th grade. Enough.
Miss Chow,
Yes.
I have a weird science fact. Technically, because of the way particles work, you can't actually touch anything. Like, you're never really touching anything.
I don't know where you're going with that, DJ.
I'm
All right. So so let's talk about how the pressure, like you're talking about, affects how solid something feels. Because you're right, a belly flop into a pool, it doesn't really feel like water. Like if I just dip my finger in there, it hurts. It stings. Like you're like, bam.
It made me puke in the pool.
Right? It hurts a lot.
I got banned.
Same as slime or that cornstarch and water mixture. Like if you hit it hard, it's a solid. But if you barely push, you can get your hand in there. Now, so think about this. If this was a container and I had the molecules, the particles, these are particles that are too small to be seen. Yeah.
I just wanted to tell you, Zeke is right in front of the camera, so we can't see anything.
Yeah.
Thank you.
You look lovely, Zeke. Okay. So
another
hang
thing.
on. What?
So if you like do like a pencil from high up or dive in water, it doesn't hurt though. Because if you
That's exactly where I was going with
if
this.
you jump in and you're like that, you just go straight in and it doesn't hurt
Okay,
at all.
so let's think about this. If I were to belly flop, This is water. Here's my water molecules. They've got room to move. They're not completely packed together. I'm covering a lot of area if I belly flop, right?
Yeah.
Okay, so all of these body parts, I need to push molecules out of the way. Lily.
Because if you're just diving, you don't really have to have that much molecules to push away.
Right. If I'm diving,
It's just like your hand.
I'm shaped like this, right?
I can cut through
I'm holding my arms like this in front of me,
surface area.
and I'm not covering as much space, right? So I don't have to knock as many particles out of my way when I enter the water. So it's easier for me to go into it, and it doesn't hurt so bad. It doesn't feel like a solid when I hit it because I just barely need to move molecules out of my way.
Another thing, it's kind of like off topic, but that guy doing a belly flop would not hurt because he's so skinny.
It would actually kill him though, because he's so small. It would break.
Now he feels the weight.
He looks like a penguin.
He's got problems. Okay.
It's bad. Give him chubby legs too. Give him chubby legs.
Make him look like Baymax, just a bunch of bubbles walking around. All right. Did that make sense to you guys?
Yeah.
Okay. We're ready to move on. Because not only do we know that solid, liquid, and gas are different because of how the molecules are able to move around inside. And those are the molecules. When I say molecules, I'm talking about those particles that are too tiny for us to see. So in oxygen, like in the air we breathe, I'm talking about oxygen, hydrogen, nitrogen, all of the different gases that are in our air. In water, I'm talking about hydrogen and oxygen. The little molecules all put together that are too tiny to be seen, okay? But there are other ways that matter is different as well. Zeke, continue reading about the amazing properties of matter.
Can I read down?
Yeah. We're ready to listen.
Amazing properties of matter. Color and shape are two basic properties of matter. Many other properties help you tell some type of matter from one another. Some properties like reflectivity and response to magnetic forces are important to scientists and engineers. An engineer designing a new type of magnetic device would not use wood to build it because wood does not react to magnetic forces. Remember the substance that was discussed at the beginning of the lesson, which behaves sometimes like a solid, sometimes like a liquid. Response to magnetic forces is a property that causes that strange behavior. Most rocks are hard, feathers are soft. Hardness describes how easily something can be bent or dented. Reflectivity is the ability to reflect light. Smooth objects like this tea set tend to be more reflective than objects that are bumpy. Miss Bev, I have another thing. Okay, so did you know, this is a weird fact, but color is different. So say, okay, Miss Bab's whistle. It's actually every color but green. Green is just the color that reflects off of it. All the other colors soak into it, and then the green reflects off of it, and that's what makes it green. So it's every color but green.
I know. So this
Okay, so you guys learned about that now.
except white.
Okay, is white a color?
So this paper is just every shade except for white.
Okay, so think about this. There are more than one type of property. So a rock, like it said in this picture, a rock is a solid, obviously, but a feather is a solid, but it's much more bendable and lightweight than a rock. It's because of the type of molecules that make up a feather are different than the type of molecules that make up a rock. Remember when I showed you the periodic table of elements and there were like 100-something different things? And each one of those things has its own properties. And then if you combine it with another thing, then it has even other properties. So like it says, some things are naturally reflective and shiny. Some things are naturally smooth. Some things are naturally bumpy. It just depends on which kinds of molecules make it up, okay? And then if you combine two bumpy things, you're probably going to get a bumpy thing. If you combine two things that are magnetic, you're probably going to get another thing that is magnetic. But these are the kinds of things that scientists figure out. They combine different things and see, okay, well, this has this property and this has this property. If I put them together, what's going to happen?
Now
What's
we
going to
have this property.
Right. Okay. So we know that people sort things by size and shape and color. That's easy. We've been sorting things to size, shape, and color since you guys were little babies over at Platten or whatever school you went to when you were little babies. Now, you might not have thought to sort things by hardness. Maybe. That one's not so hard. You might not have thought of sorting things by if they're magnetic or reflective. Here's another one you might not have thought of, turning the page, conductivity. DJ, you want to come read?
Yeah, and I also have something to say. I know that air also is there because it has friction because you have a terminal velocity.
Yes. All right. Well, I've actually talked about terminal velocity before. Things can only fall at a certain speed. It'll eventually not fall any faster.
Yeah.
So like if I were in a plane and I dropped a bowling ball out of the plane, it would get faster and faster and faster up into a certain point, and then it would fall at that same speed the rest of the way.
Yeah, like if you dropped the bowling ball and it started at 20, then it went to 40, then it went to 60, and then 80, and it wouldn't go any faster if that was its terminal
Right.
velocity.
Terminal velocity is the maximum speed that something can fall. And each object would have its own terminal velocity. That's another property
Like
of an
a
item.
car, it can only go so fast.
An
easy way to test that would be like if you had like a portal from the game portal, like a portal gun, and then you put a portal on the ceiling on the floor.
That's an easy way to test it if I had a portal.
Well, I mean, like if that existed, that would be an easy way to test each object because it would go infinitely.
All right, I would love to read about conductivity instead of hypothetical portals. All right, let's talk about real conductivity. Hang on, pause. Lily. Yeah. All right, we're ready. Girls.
You already have learned about several different properties that matter can have. Add to one, or another one to add is to the list of conductivity. The ability to transfer heat or electricity. Things that are conductors are made of metal, although other materials can be conductive as well. Materials that do not conduct heat or electricity are called insulators. Insulation is often made of cloth, plastic, or rubber. In fact, have you ever noticed what covers the electrical outlet cords in electric devices? The wires are covered with plastic to keep the electricity heat from flowing outside or out and starting a fire.
All right, perfect. Thank you, DJ. So think about that. So conductivity, have you heard of something's a conductor? A conductor is something that gets hot or draws electricity. Something that's likely to get struck by lightning is a conductor.
So windows.
So metal things are way more conductive than wood.
Lightning rods are made to
Okay.
get struck by lightning.
So metal things, if you think about this, if you're cooking on the stove and you've got a pot of boiling water and you left a spoon sitting there to stir with, kind of in the pot, it gets really hot. And like maybe even burns you if you try and pick up the spoon after it sat there in that boiling water and try and stir with it. But what if mom has or grandma has a wooden spoon? Does that get us hot?
Yes.
No.
Yes, does.
No, it doesn't, baby, because wood is not a conductor. It will get warm, but it won't get warm enough to burn you unless it were to actually be like on fire. But now, but no. Flammability, that's the ability to catch on fire, is different than conductivity.
Wait.
Hang on. I'm all done with the funny guy routine. Got it?
Hey, Miss
Cool.
Bell, I just thought of something. So flammability is something. But is there like a thing with like melting, like metal? If you put it in like lava, it'll melt. Is there something?
Well, that's just its melting point.
Yeah.
Every property has, every element has its own melting point,
Like
its own boiling point. Yeah. So like ice always melts at a certain temperature. It can't stay frozen.
That.
Yeah.
That's
Freezing
why
point,
some-
melting point.
Yeah.
That's
Okay.
why some drills are covered in tiny pieces of diamonds because diamond has a very high melting point.
Right. So depending on what the element, it has a different melting point that it actually just liquefies. Now, Sophie, hang on just a second. Yeah. So Sean, I think, got a little confused with flammability because he's like, no, wood can get hot. Yes, if it's on fire, but that's flammability. Flammability is an object's ability to catch on fire. Things like your clothes and wood easily catch on fire. My shirt, my jacket would catch on fire a lot quicker than my desk.
What about my shoes?
Okay. Some things burn easier than others. Some things draw heat better than others. When we're outside, think about on a hot summer day. Would you rather stand barefoot in the grass or barefoot on the concrete?
Grass.
Grass, right? On a hot summer day, you do not want to be barefoot on the concrete.
But I also don't want to be
It's going to burn.
You
Okay,
don't want to wear a black shirt on a hot summer day because black absorbs light.
Right.
One will get too cold.
Okay.
One will get too hot.
and again, a metal spoon in a boiling pot of water is going to get too hot to the touch to use it. A wooden spoon does not get that hot.
So the other thing I thought of, so like, I know, well, me and my dad have been learning about like forging like knives and stuff, but for like, because we're gonna do that soon, and so like, there's this way to make handles. Like, you make a mold out of sand and you melt metal and pour it in there. So like, there's like, and the metal looks like the metal when you melt it, it's like a shiny liquid, and it's like. It like really reflective.
Yeah, I'm done with you mucking me and all of that. You're over here. I'm in the hall. I'm not arguing to keep people in class. When I see you having something happen with your phone, I stay out here for a while.
But like it still has its own like reflective because the steel is reflective before it's melted, and then once you melt it, it's still like shiny and stuff reflects off of it.
Right. I have no idea what you said since I had to deal with that, but I'm going to go with, yep, you're right.
Yeah, because it has like the same property of reflectiveness when it's a liquid and a solid. The metal does.
Okay.
Because like when you melt it, you can see it's like light shines off of it.
Yeah. Yeah. Yes. Okay. So if you wanted to read below these two pictures. Okay. Yep. Go ahead.
Using a metal spoon to stir the pot could result in a burn to your hands because metal conducts heat from the boiling water. Using a spoon with a nylon handle is a much better idea. Nylon does not conduct heat as well as metal.
All right. So nylon is another option. I have wooden spoons in my kitchen, but you might have like some hard plastic spoons or some kind of rubbery silicone spoons or things like that. Those don't conduct heat as much either, so you're not going to get burned. Now, if you leave those too long on the side of a hot pan, they can melt. I have a silicone rubbery little spatula that I use like when I make eggs, and I've left it kind of sitting leaned on the side of the skillet before, and it melts a little like ridge in the little plastic spatula before.
It gets
so hot. So that melting point, it doesn't conduct the heat. It doesn't hold heat throughout the whole thing. It just melts it in that one spot. Jason.
Well, how do, like, so you know if you have those metal hands, like when you pick up the pan, like the handle ain't that high, but the pan would be, but the handle and the pan are the same thing.
Yeah, but usually the handle has a coating on it. So your pans on the stove, almost always your handles are going to be made of a different material because it's going to be coated in some sort of rubber or plastic so that you can grab it. Now, certain types don't have a different kind of handle, and you do need to use some sort of like heating pad to grab them. Like I have some like stoneware type pieces or some cast iron pieces, and they don't have a rubbery handle to them, so I have to use like hot pads to pick those up. Yeah, or I would get very, very burned and sad. Okay, dissolving and evaporating. Who wants to read that for me? Fiona. Come on up, and I'm going to go talk to this other little
Like the only things that will make me shut up.
But cheese?
I don't
use
Okay. Dissolving and evaporating. Matter has so many different properties that it is hard to keep track. Another property of matter you should consider is solubility. Dissolves, which is the ability of one substance to dissolve in another. When something dissolves, it may look like one small substance has disappeared, but those particles are still there. They are just too small to be seen. If you let salt water evaporate, for example, you will be left with a pile of salt. Think back to the activity you did when the salt in the water, after you stirred the water with the salt in it, was salt still there? You could not see it, but it was still in the water. It had dissolved.
All right. Thank you, Fiona. Yes, ma'am, Josie.
Okay, so I forgot to throw away my saltwater, no, my crystal making thing. So mine did not make crystals, but it was really cool. I'm not going to bring it in because my dad put it outside and a bunch of bugs got in it. But it had like a layer of mold all inside and like a layer of mold at the bottom that was just like floating around.
Interesting. Probably because some bacteria got in there and started like getting moldy. Yeah.
I have two things. So this was recently. Well, I found out this morning. So I have my knife and I cut a piece of cheese with it, and I didn't clean it all off. So it started molding because there was cheese still on it. It started molding, so I have mold all over my knife right now. And another thing is, so I had beef jerky, yeah. It was in a bag, and after like a year in there, it turned yellow, and it was like crusty and yellow.
And why did you just keep beef jerky in a random bag for a year?
No, it was in the beef jerky bag. It was like in the bag it's supposed to be in.
Oh, it just got bad.
It was like all yellow and crusty. I thought it was a cracker.
Crackers are good.
No, I didn't eat it.
Crackers are good.
I already got food poisoning and died.
All right, Zeke has a year-old moldy beef jerky that looks like a yellow cracker. All right. Right. Can what? Maybe later. All right. Here we go. Mixtures and solutions. What is it? Are we ready? Imagine you are making a drink from a mix. Like, I don't know, like Kool-Aid or like the lemonade powder, something like that, right? Okay. You add water to a pitcher and then add a packet of your flavor crystals. You take a spoon and stir everything together. Other than a tasty drink, what have you made? Adding these things together forms something called a mixture. A mixture is a combination of two or more different substances in which the substances keep their identities. If you sip the drink you mix, you would taste the flavor that was added to the water. All right, looking at the picture below. So a mixture, I put two things together, but each of those things is still the same as it was before. So if I were to make lemonade, it has the lemony flavor of the little powder that I put in it, but it's still a liquid like the water. Okay, so each of the things remains the same. Now, in the picture on the left, it's hard to tell since it's not in color, but that's a salad. And it says the salad is a great example of a mixture. Even though that's all mixed together, you can still see all of the different things that you put in there. The lettuce, I think that's an olive. There were tomatoes in the picture, several different types of lettuce. And we could separate that back out really easily too, couldn't we? Yeah. All right. Some types of orange juice are made by mixing water with a smaller volume of concentrated orange juice. Has your parents or grandparents ever made the orange juice where it's like frozen orange juice in a can?
Yeah.
And then they add water to it? Okay. Or
all the time.
Yeah. I feel like I don't see a lot of that
and you mush it up
recently, but it's called frozen concentrate, and it's like the frozen pulp of all of the fruit. So like you could get it. apple, orange. It comes in like other grape. And so it's actual like frozen grapeness.
Yeah, I
And you put it in water and it melts and sloshes around and you kind of have to smash it up because it's kind of frozen, a little globby. Now, again, it kind of looks like a slushie at the very beginning when you first take it out of the can. Now, that's a mixture because, again, I start off with orange flavor stuff. I put it with water and it turns into orange juice. It's got the liquid properties of the water, but the flavor of the orange. Both things are still in there, and I know they're not something brand new. Okay?
Does lemonade have salt in it?
No.
Sugar.
No, sugar.
Sugar.
No. Gatorade has salt and electrolytes in it. Like Gatorade and those kind of sport drinks, Powerade, that kind of stuff does.
That's why I like
They're
sodas
salty.
so much.
But
Yeah, because it makes you want to drink more, so you buy more.
What?
salt helps you. Here, you want to know the skinny on this? Salt helps your body retain water, which means hold on to water. And it's for sporting, usually because when you're sporting, you're working out, you're working hard, your body's using all of its resources, it's burning all of its water up. A lot of times you're sweating and you're losing water and you're getting dehydrated pretty quickly. So the Gatorade and the Powerade, that's why they call them sports drinks, because you drink them a lot when you're working out or after a workout, because it helps your body hold on to the water so that you don't get dehydrated after a workout.
Yeah, like another thing is like I have one of those Gatorade water bottles,
Right?
and you have those capsules of juice, and you fill it up with water, and then you have the capsule of juice, and you put it in there, and you smush it down, and it all comes out, and then you throw the capsule away, and it makes Gatorade water.
Okay. I've never seen that, but I believe you. All right. I'm continuing to read. In a mixture, each part keeps its own properties. Have you ever accidentally swallowed ocean water?
Yes.
If so, then you've tasted a mixture, water and salt. Mixtures can often be separated. If you leave a dish of ocean water out in the sun, the water evaporates, but a small pile of the salt remains. Okay? Just like in the salad above, I can easily separate that back out into the different types of lettuce, olives, tomatoes, cucumber.
Flavor out of the orange.
All right. In the pictures below, it's hard to tell what those are, but it says you have a mixture inside of you. Your blood is a mixture made of water and different types of cells.
Miss Bab, another thing.
Stop interrupting. Raise your hand and then wait. Some of these cells carry oxygen. Others fight off infections. Other parts help the blood to do something that cut off the page. Don't know. Can't read it. All right. And then go outside and look at the street, the picture on the right. It's another type of mixture. Asphalt is made of different sizes of particles. A heavy machine blends and presses these particles, and a type of concrete is made. So it literally takes a bunch of different types of rock stuff and just smashes it together really tightly. And that's how you get the concrete. Okay? That's a mixture. Okay? It's different things, but I can see each of those different pieces if I were to look closely at the concrete, at the blacktop. Okay? Now, something that is different from a mixture is a solution. Jason, yes?
So, like our salt things,
Right?
there was salt in it, and we could kind of see some at the bottom. But
It was
in Gatorade, we can't see any salt.
They mix it
they mix it really good and it's not at its saturation point. So when we did the crystals, we overly saturated the water. And that's why many of you could still see a layer of salt at the bottom of your jar. We overly saturated. And so what that means is there's only a certain amount of salt that can dissolve in water. Okay. And then there's no more room for the salt to dissolve. And so we put so much salt in those jars, there was nowhere. All of the salt had attached to a water that could, and there was salt left over that couldn't dissolve because it had nowhere to go. And so it just sat in the bottom. In Gatorade and Powerade, you can't see the salt sitting at the bottom because they've got just the right amount in there. There's more salt in Gatorade and Powerade than there is in plain water or others like fruit drinks like Kool-Aid or juice or anything like that, because those drinks don't have salt in them at all. but they add just enough salt because the reason those drinks are like that is because those drinks are meant to help your body retain water so you don't get dehydrated when you're doing sports. Okay. So now we're going to flip over. We're going to talk about the other kind of thing that happens when you mix things together. You get a mixture or a solution. Okay. See.
So another thing is I noticed about like blood. So like if you like bust your lip and like taste some blood, it has a metallic taste to it.
It does. Because there's iron. There's a high concentration of iron in your blood. Yes. If you can taste, like a lot of times if you lose a tooth or, I don't know why else you'd have blood in your mouth. Or if you like bust your lip or something like that. Blood has a metallic taste to it because there's iron in your blood, and there might be some other trace metals, but I know iron is one of them. Okay, now, what is a solution, girls? I'm ready to teach. I hope you're ready to learn. What is a solution? Some mixtures are obvious, such as a salad. Other mixtures, such as ocean water, are so well blended that it's hard to know they contain more than one thing. A mixture that has the same composition throughout because its parts are mixed evenly is called a solution. Think of lemonade, ocean water, and orange juice. Can you see the different parts that make up the liquids? Nope. That's because the solids, like the sugar in the lemonade, have dissolved into the water. These particles are too small to be seen. You can taste them, but you can't see them. How could we collect the solids? As with the salt water, you could let the lemonade sit out in the sun until the water evaporates, and you would be left with a pile of lemony sugar.
I'm going to do that.
Are we going to do that? And I wasn't planning on it. All right. Ocean water is a great example of a solution. What kinds of things can be found in it? Ocean water has a lot of dissolved salt in it, which is why you can't drink it. All of the organisms living in the ocean have ways to drink or absorb water, but avoid too much salt. Ocean water also has small amounts of other substances, including calcium and potassium. Adding food coloring.
Banana.
Adding food coloring to water is a good way to observe how a solution is made. When the coloring is first dropped in, like the picture on the left, you can still see it distinctly. But after stirring it, the colors spread out evenly in the water, and you can't see where the color starts or the water ends, right? So like when we dyed our crystal water, when I first put the drops in, you could see the drop kind of going in. But when you guys stirred it around to mix the salt and the food coloring, you couldn't tell. You could see some salt in the bottom because, like I said, we overly saturated it on purpose.
But
if I put the correct amount in there, you wouldn't be able to see the salt or the coloring. Okay?
What if we dyed the salt and then put it in? We did that.
Josie asked about that too, I think. What if we dyed the salt and then put it in? The water would turn a color. It would all mix together, and it would be a solution. All right. Josie.
That'd be messy.
So that was not what I asked, but you told me to keep on reminding you. Can we, once you get an extra penny, dip the penny in vinegar and then put it in just regular salt so it's not dissolved?
Yes. I'm putting my wallet on my desk to remember to look because I tried to remember to grab pennies, but I have no idea what the years were. I just grabbed a handful of pennies. Now, okay. All right.
Don't get any of my pennies.
When you think of solutions, you probably think of liquids. However, solutions can also be mixtures of gases. The solution of gases that you're probably most familiar with is air. Did you ever think that air is a solution?
Yeah.
Okay. Nitrogen, carbon dioxide, oxygen, and some other smaller gases all mixed together to form this mixture, the solution that we breathe. Okay. Hello, Gracie girl.
Grace, are you staying in this class now?
No, she's in fishies. Thank you, ma'am.
She's in fishies.
All right. Separating mixtures. You now know that mixtures are combinations of matter where each part keeps its own properties. Thinking back to the salad, what kinds of things did we see? If we wanted to remove all the carrots and cucumbers, could we?
No.
Of course. If I ordered a pizza and you didn't like mushrooms, could you pick it off? Yeah. Right? Okay. Those are mixtures. We can easily separate them. But sometimes solutions need to be separated. And there are several different ways this can be done. Some of these ways involve the use of advanced equipment, while others use very simple methods. Now, think about this, because solutions are the ones where they're mixed really, really well together and you can't even see the parts of it. What if I wanted to separate the lemonade, but I don't have time to wait for the water to evaporate?
We use tweezers.
Can I tweeze out the bits of lemon?
Yeah.
Do you like water it down?
No.
Water it down, add more water to
It's a
it.
filter.
There's still, to get a filter.
Let
Okay.
it wait a couple of days.
Well, okay, you could just wait.
No, but they just said that we don't have time to wait.
If I don't have time to wait, I do like the filter idea. That might help with some types of solutions, okay? So let's,
Remember the little paper towel thing that we used with the pepper?
oh, the paper towel and the pepper experiment. I remember that. And we did that filter, like the nephrons that are in our body was what we were learning then. All right.
Yeah,
I remember that. Yeah, you could separate out some things. You would have to have a special type of filter paper. Oh, wait, Miss Bab ordered a special kind of filter paper. We were going to separate some things today, but the filter paper didn't come in. A special kind of filter paper. So, like, we think about, like, we use the paper towel with pepper. But pepper particles are big. We can see pepper, right? Yeah, I can see pepper. My eyes can see pepper. Now, I can, and then also like coffee. If you're making fresh coffee, your parents put a filter in there, and then they dump the coffee grounds in there, and that coffee filter keeps all those grounds from getting in the coffee that we drink. But again, coffee particles, I can see the coffee grounds. They're not that small. So to trap the particles that are too small to be seen, I need a special filter paper that is even tougher for things to get through. So it lets even less through. Because if I were to pour lemonade over a paper towel, I'm pretty sure the water that comes through would still be mostly lemonade. I might not have pulp. So like, you know how orange juice has like the pulpy parts in it sometimes? I could filter out the big pulp pieces with paper towel, but I guarantee that what came through it would still be orange juice because the orange flavoring is not big enough to be stopped by a paper towel. So we have special filter paper coming.
That you pay for in school.
Does it matter?
No.
Yeah, it wouldn't make sense if you pay for it.
I paid for it.
School.
I paid for it.
Yeah,
Because I love you and I want to show you this.
That means
Okay.
they care for
I
us.
might actually ask them.
When I do care for you. If you guys haven't figured out how much I care for you by now, you're crazy. All right.
Sam, can they put those disinfectant lights in lemonade? There's no lemon on it.
It's lemon scented. They probably added a fake lemon smell. All right, here we go.
All right.
When particles are mixed so well together that other separation methods don't work, sometimes scientists have to resort to very advanced techniques. DNA is the part of your cells that carries the code for all your traits that makes you, you. None of us have the exact same DNA. Some of us have girl DNA and some of us have boy DNA. Some of us have blonde DNA and some of us have brown hair DNA. Some of us have DNA that makes us more shy. Some of us have DNA that makes us more outgoing.
Some DNA makes you silly.
Some makes you the class clown. Isn't that funny? All right, now, because there is so much DNA inside each cell, scientists need to separate different segments to be able to read it. They do this by sending electricity through a gel that has segments of DNA at one end.
Ultrasound.
Okay? The different size segments travel different lengths along the shell, creating a DNA fingerprint.
Is that what an ultrasound
Okay.
is? What's an ultrasound?
Now,
Don't do it. Don't say it.
Hey, Miss Bab, what's an ultrasound?
an ultrasound is a
You use
machine that
gel
sees
for it.
inside you.
Yeah, but you use gel for it.
They do use gel, but that's not this. Okay, listen up, class. Why are some of you talking while I'm up here teaching? I don't appreciate it. More and more and more, you guys are just like I'm not even up here. Enough. Get it together, guys. Okay. All right. I have no idea what that bell is for because we don't go outside for another 10 minutes. Now, Jason, yes.
Is there a meal level? Oh my god.
I have no idea. All right. Now, okay. So there are lots of different ways. Filter paper isn't the only way to separate out solutions. They just said that they run electricity through this special gel and it causes the things to move in a certain way that separates them. Okay. Scientists have figured out lots of different ways to separate things that are too small to be seen, but they all require special machinery that we don't have here in the classroom. Really, the only special thing that I can get here in the classroom that's even remotely affordable is this special filtered paper. So when it comes in, we're going to take the solutions that's inside of a marker that makes a marker the marker, and we're going to separate out the different colors. It's called chromatography,
Miss Val,
and it's a way that scientists study colors and what makes colors. Like you guys were just telling me about how the light absorbs and reflects certain colors. This is one of the ways that scientists can separate out colors to their basic color and study them further. Okay. So as soon as we get the filter paper in, we will do this activity.
Miss Val, I actually might have that paper at home. So I might have had one or two for the chemistry set that I got at my house. I've in the book it actually told me to do that, and I've done it before.
Awesome.
I might have an extra paper to do it.
I've got 100 sheets of this because I bought enough for all of 5th grade coming.
Miss Val.
It's tiny.
They better be paying you back.
It was $6, man. I got it.
No, they
It was Lils. Is who coming back? Josie's back next week. Yes. Grace is back, but she's in Fisher's room. Okay.
Miss Val.
All right. I thought we were getting Grace. As of yesterday, we were supposed to have Grace, and then it changed last night, and now she's in Fisher's room. That's okay. We just got so many kids. So, but Josie, you're for sure mine. I know that for a fact. So, well, when Grace started the school year, she was in Miss Fish's room. So that's why she went back to Fisher's.
Miss Val.
Well, I don't know what to tell you about that. Some of you just got lucky.
I got lucky. I was supposed to be Miss Fisher.
All right, now, this is all we've got for today.
Can I get eye drops?
Yes. All right, so I'm going to hit stop record for now. Z, guys.
Another thing is, don't you have like enough DNA to wrap around the world like twice?
I have no idea
Don't you
about
have
that
like
statistic.
Don't you have like 2,000 miles of DNA?
2,000 miles of DNA.
That's nowhere near enough.
This is a new one. That's a new one. I really don't have that many, but
Impossible.
No, Miss Val, look up how many miles of DNA do you have?
Well, it's certain because the older people or elderly.
I got one. Josie, I got one. What do you want me to do? Put vinegar on it first and then put it in the salt?
Like just plain grains of salt.
Hey, whoa. Class. Zip.
Because I wanted to see what it would do if the salt's not dissolved.
So put it in vinegar first and then just put it in a bowl of salt. Okay. All right, let me do that real quick. Yeah.
Did you know dinosaurs could exist to this day? Because mosquitoes were in the dinosaur age.
That's the whole basis of Jurassic Park.
Yep.
They've actually recently found a dinosaur with skin still on it.
Interesting. I did not know that.
Wow.
Okay.
Was it in the time capsule?
You
You're
guys,
it's laying on the ground.
1%.
Yeah,
it's like, it's just like laying on the ground.
She's
Somebody
sure
was walking the dog like,
Oh,
a dinosaur with skin still on.
It was like in the
Oh wow, what is that?
Josie's experiment. Oh, class.
Oh, yes.
Josie wants to know if we left these two things separated, Why are you here? I'm going to pin this. Okay. If we leave these two things separated, the salt and vinegar, we know that last week we made a solution of salt and vinegar, right? And Jason and Sean go in the hall. Bye.
Miss Bev, I don't know. Can you look up how many?
I'm in the middle of an experiment. Okay. All right. So we know that when we had the solution of salt and vinegar, it cleaned the penny.
Can you pin yourself?
So here's my penny. Let me pin myself so you guys can see. Josie's question is, if I do it separately, I've got a cup of vinegar. I'm going to dump it in, and then I've got salt, okay? And here's my penny. This is the level of dirty we're talking about right now.
You can't see it, Miss Bev.
What do you mean you can't see it? It's
No.
that dirty.
No, the cups you can't see.
I know. I'm going to hold it up. Okay, so I've got my penny and vinegar. Yay, vinegar. Now I have a vinegar finger. Okay, and then I'm just going to put it in the salt, and I'm going to shake it so that it gets like buried in there. Okay, he's down in there. And I'm just going to leave that while we're at recess.
How do you know it's a pea?
And then when we come back from lunch, we can check and see if he is cleaner like he got last time, or if he is still the same. Does it work when it's not a solution if it's different things separate? Very interesting question. We will now finally find out the answer. You are welcome, Josie.
Can you look up how much DNA you have?
Okay. All right. I'm going to hit stop record. And you guys are good to go, and I will see you later this afternoon. We are doing writing finally today.
Yay!